Okay, exploratory data analysis. Okay, so remember class, I asked all of you to study the Titanic file, okay, Titanic data set, and I shared two links also. One Wikipedia link I shared about Titanic, okay, and one link I shared about Kaggle, right, from where we downloaded the data set. Okay, so I asked all of you to study that. I hope all of you have already done this part. So I'm continuing from there only. Okay. So class, we will first take this Titanic data set. With this we will import and period.read underscore save Titanic.css. Titanic.css is already present in the same folder in which my main code is present. Okay, it is already there. So here you can see there are 891 rows. There are 891 rows and 11 columns. Now class, the first like obviously since you are going to do EDA, so it is totally dependent on you and the type of application that you are working on in the project. Okay, right now we are doing an open-ended EDA. That means we don't have any specific application in mind. Okay, obviously we don't have any client right now. So we took a data set and we're going to do complete EDA on that particular data set. Okay, so in that case, what we do generally class, okay, we basically do three things in the starting. Okay, we first make the correlation matrix. Okay, now what is the benefit of making correlation matrix? Correlation matrix basically gives us the relation between different columns. Okay, how different columns are getting affected due to each other. Okay, that is your correlation matrix. First thing, second thing that we have to do is we have to make a heat map from the correlation matrix. Second thing, and third thing that we have to do, class, we have to make a pair plot. Okay, if you remember in the Seaborn class, I covered the pair plot also. So pair plot is basically it is a plot of it is a scatter plot between different columns. By default, it is scatter plot, but we can take other KDE plot also. Maybe we can take hex plot also. Okay, we can take your regression plot also. Okay, so that plot can be created using pair plot. So pair plot gives us relation between multiple numerical columns. Same goes with correlation matrix also. Same goes with heat map also. It will give us the relation between all the numerical columns. Okay. Now class, in order to continue further, okay, we need to see that how the numerical columns and how the columns in general are connected to each other, are related to each other. Now in the data set class, in the given data set, here you can see we have survived column, that is numerical column. Okay, and they basically seeing which columns are numerical. There is survived, there is P class, okay, there is age column, there is SIBSP, there is Parch, okay, there is your fair. Okay, these columns are your numerical columns. Okay, rest of the columns that we need, okay, but they are not numerical. So there's your sex column, your cabin column, and the embark column. These three columns also we need, okay, but they are not in numerical format. So now what we will do, class? Okay, in order to convert them into numerical, we will use the method that I've already covered, replace method. Remember, so we will write df dot replace or df dot sex dot replace. Okay, and then in the bracket we will mention two things. First male comma, and then we have to replace male with some number. So suppose we are replacing male with, let's say, 1. We have to make it into numerical column, no? So we can take male as 1 and female as 2. It is totally up to you. Totally up to you what two numbers you want to take. You can take male as -1, female as 1. You can take male as 10, okay, female as 20. Anything that you want to take, you can take it here, but you have to convert it into a numerical format. Same goes for cabin now, class. In the cabin, you can see it is like this C85, C123, okay, your C123, B42, C148, and so on. Okay, so we don't need the whole Kevin column. We don't need the whole Kevin data. We just need the deck. Okay, we just see here C deck or B deck or D deck. I told you, right? There are 7 decks in total: A deck, B deck, C deck, A, B, C, D, E, F, G. From A till G, there are 7 decks on the ship. There were 7 decks on the Titanic ship. Okay, so from the Kevin column, the first index, that means the 0th index, is giving us that data class. So now we have to create a separate column here in which we are going to store this data. In which we are going to take the first index, sorry, 0th index value from each and every data point in the whole Kevin column and save it in a separate column class. So now what will happen eventually? In the separate column, there will be, we can name the separate column as deck. Okay, in the deck column, we have to say save NaN because null value. Okay, and then C, the null value, then C, the null value, and then here null value, then B, null value, C, null value. So we are going to store just the deck. Okay, I hope all of you are clear so far. Okay, if you have any doubt, please ask. Okay, now after this class, after this, once we have the deck with us, so now there are 7 decks. Now we can allocate numbers to each one of them. We can say that A is 1, B is 2, C is 3, okay, D is 4, and so on. Okay, so we can allocate numbers to each and every deck. Okay, now same thing we have to do with the embarked column also. In the embarked column, there are 3 values possible: S, C, or Q. Okay, so S value we can give, let's say maybe 1. Okay, C value maybe 2. Okay, and Q value maybe 3. Okay, or -1, 0, 1, whatever value you want to take, you can take it. That is your embarked column. So class, now what you will have? Our sex column, embarked column, and the deck column. Okay, these 3 columns you will have in numerical format. So right now you can see in the correlation matrix, it is just taking the numerical columns. Then it will take these 3 columns also, because they have been converted to numerical format. So you'll be able to understand the relation between them. Okay. Correlation matrix I have already explained. Okay, how to read it in the Seaborn class. Okay. Now class, I am going to check here. Okay, I am taking randomly. Like I can take columns randomly. Now I saw that, okay, in the Kevin column, now there is a lot of missing data present. So first step class here we saw in your EDA was to make a correlation matrix. Okay, then make a heat map and make a pair plot. I have not created heat map and pair plot right now. Once you do this, you will be able to make relations between the columns. Study the relation, how you can study how they're getting affected because of each other. Then continuing from there, next step is to handle the missing data. Here I saw that in the Kevin column, there is a lot of missing data. Okay, so now we have to check it, at how much missing data is actually there. Okay, so I will simply write here df.kevin is df.kevin.isnal.sum. I've already explained this code also earlier. Okay, in pandas. Okay, so you can see there are 687 null values present. 687. Now we have to see 687. Now I will basically set it. Okay, how many values, how much percentage, okay, how much missing, how many missing values are there in percentage format. I have to check. I will run this code. There you can see it is giving us 77%. Right, 77. 0.77 means 77%, right? I have to multiply with 100 also. Okay, 77% missing data is there in the Kevin column, and that is a lot. Now class, now it is your responsibility. Now as a data analyst, it is totally up to you whether you want to drop that whole column. 3 possibilities are there. Either you can drop the whole column, okay, or you can drop the rows only. Okay, you can drop those rows. Suppose you can drop the first row. Passenger ID 1 you can drop. Passenger ID 3 also you can drop. Because wherever there is null value in the cabin column, you can drop those particular rows. That is the second method. Third method that you can apply here is you can put some data here. You can put some kind of data here. Okay. Now, how to fill up this data? How to fill up 77% of the population data? That is something of a task here. So let us understand that in this case scenario how we can do this. Now, class, focus on one thing. Now, that when we are talking about the ticket column, right? Ticket column. So when P class is one, when P class is one, see the ticket column. It is starting with 111, na? When P class is one. Same thing with P class is two. It is starting with 22222, right? When P class equal to 3, so here ticket we have line. Okay. But when P class is actually 3, na? Okay, you can see the data set also when P class is 3. For example, here, see, last row. When P class is 3, it is starting with 3. So here class we can see that the ticket number is actually giving us some relevant information. The first digit of the ticket is basically giving us the P class. Now similarly, I don't know. We are doing EDA right now. Okay, so I'm just giving an idea right now to you. Okay, that see, we saw it in the P class. Your ticket column, the first digit of the ticket is representing the P class of the passenger. Now there is a possibility that the second digit, that means here, the second digit, or maybe the third digit, or maybe the fourth digit, or maybe the last digit, or any digit for that matter in the ticket number, there is a possibility that it is representing the cabin. Maybe here 1 means C, or maybe 13 means C, 13 means C. Okay, here maybe 11 means C. Okay, here B42 112, 12 means B possibly. Okay, we have to find out some pattern. I'm just giving you example right now, random example. There is a possibility that there is some kind of pattern in the ticket column. So that is what you have to do, class, here. Then in this case you will run a query. See, df cabin dot is null. So here you can see it is giving all 87 rows where there is a null value in the cabin column. Now what we will do, class, here we will put a negation sign. We will take this whole thing and we will negate it. Now here you can see, class, in this case it is giving us all the columns in which there is not null value. Null value is not there, it is giving us those columns. 200, those rows, sorry. 204 rows it is giving us. Either you can use this or this can also be written as instead of writing is null, write not null. Same code. Both of them are same code. Okay, here we are negating it. Okay, see, this will work only when there are two possibilities, either null value or no null value, right? Either null value is there or null value is not there. So in that case, this we can use. Right, class? So Kevin column we have done. Okay. Now think about it. We have already taken out the deck column also. Now based on the deck column, you will take deck. You will make a separate data frame for deck A. Make a separate data from deck B. Make a separate data frame for deck C. For D, for E, for F, for G. For all of them, we will make a separate data frame. So 7 data frames you will get. Now you have to study the ticket column. Ticket column and the Kevin column and see if you can find some similarity between the two. Okay. And then on the basis of that, think about this in this manner. Suppose let's say we have a lot of missing data in the P class column. We have a lot of missing data in the P class column. So you can always go to the ticket column and we can take out the P class data from the ticket column also. See, ticket column is not necessary to for us. Otherwise, we don't require the ticket. We don't need the ticket column normally. Okay, but the other columns, see, ticket column is not going to affect the survivability of a person, right? If the person survived or not, we are not going to get that information from the ticket column at all. But the ticket column is going to help us find information about other columns. Okay, maybe we will be able to check that if the person was male or female from a ticket number possibly. I'm assuming right now. I'm giving exam idea. Okay, maybe we are able to get that. Okay, embarked location also, right? Embarked location also from the ticket column. Okay? So if there is some missing data in the embarked column, so we can take that out also from the ticket. Okay, class. So that is that. Okay. So based on this class, you will handle the missing data. Okay. Now this whole thing that I explained you, I based this on the fact that you will be able to find some pattern. Now let us say you are not able to find any pattern in the Kevin column. Okay, so in that case, what you can do, you can put data. You cannot put data. Sorry, randomly. Okay, frame this again. C class. Depending on the importance of a particular column, okay, on the outcome. Here the outcome is survived. We have to check if the person survived or not. We are checking the survivability of a person based on different factors. Okay, so now if we have to work on this, if we have to work on the survivability, then we have to check that which columns are more important, which columns are less important, which columns are not important at all. Okay, now here I will use a term called as weightage for this. Okay, all of us have already used the term weightage, right? Let me remind you. Okay, all of like in your exams, during your exams, your college exams, okay, you use, right, this term weightage. Correct? Okay, how much, like for different topics have different topics have different weightage in the whole course, right? So you use different terms for different topics there. A different weightage is allocated to different topics, sorry, right? So now in this case class, weightage, what is the meaning of weightage? At how important a particular topic is from an exam point of view, right? For the exam, which topic is more important, which topic is less important, which topic is not important at all. Similarly, here in your data frames also, in data science also, what we do, we allocate, we gives weightages. Okay, right now in the starting as a data analyst, it is your responsibility to allocate them some weightage from your end that you think. Okay, your correlation matrix is giving a very like good idea of the weightage. See, on the survived column we have to check weightage. So P class, right? See P class weightage on survived. This is not exactly weightage, okay, it is correlation, but you can calculate weight, you can take weightage also from this. Okay, maybe you can say 0.3 is the weightage of P class. Okay, age is 0.07. Okay, fair is 0.25. Totally up to you how you want to give the weightage. But remember that the total sum of all the weightages that you're allocating for a particular column should be equal to 1. The sum total should be equal to 1. Like the weightage of P class, the weightage of fair, the weightage of age, SIB, SP, parch, the weightage of all these 5 columns on the survived column, on a single column on the survived column, the sum of all these 5 numbers should be equal to 1. Can be less than 1 if if you don't want to give any weightage to some column, that is fine. Okay, but maximum should be 1, basically 100%. No? So you will say, okay, this topic is 40% important, this topic is 20% important, this topic is 30% important. 30% means 0.3, 0.4, 0.2, 0.15, whatever you want, whatever weightage you will assign. Okay, now class, what happens whenever we are assigning the weightages? Okay, so like, weightages are assigned basically on the basis of importance, right? Now on the cabin column, so the cabin column you will allocate some weightage class. Now from our own experience, from our own past experience, or from our own study, domain knowledge, or whatever, okay, we know that higher the deck on the ship, okay, higher is the possibility of a person's surviving. Okay, okay, your A deck was the topmost deck, and G deck was the lowermost deck. A was the uppermost, G was the lowermost. Now, the person who is residing in the residing in any column, any cabin in the A deck has more chances of surviving as compared to a passenger who is residing in the G deck. This we know from the domain knowledge class. That means the cabin column is important, right? That means the cabin, the deck column is important for us because that is giving us the survivability of a person. Okay, so now in this case, you will see that okay, how much data is missing and how much it is important. So suppose if I say it is 0.3 important or 0.4, I am allocating 0.4 weightage to the cabin column. Okay, and at the same time I saw that okay, 77% of the data is missing. Okay, so 77%, okay, is a lot. Is a lot. So in that case, I will drop the cabin column altogether. Completely, I will drop the cabin column because 77% is a huge thing for a 0.4 weightage. Okay, but suppose the weightage is 0.6 or 0.7 maybe. That means that particular column is very, 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 very important. So in that case, you will not drop the column even if it is 77%, even if it is 80%. First thing. First thing that you have to do. Second thing, whether you should drop a column or not is also dependent on the fact that how much data is there and how much variance is there in the data. Suppose I have 1 lakh data records. See, right now we have 891 records. Na? Total, we have 891 data records. Total, we have 891 rows only. Suppose we have 1 lakh rows in total. Now, out of 1 lakh rows, assume some data in that there is 1 lakh rows. Now, out of 1 lakh rows, 70% of the data is missing. That means you still have 30,000 data records. Think about this, class. 30,000 data records is still a very huge number. It is still a very huge number. So in that case, even in that case, you will not drop the whole column. Rather, what you will do, you will drop the 70,000 rows from the data set. Okay, but again, you won't. Okay, this is not to be done always. Why? Because let's suppose there is a very high variance in the data. There is a very high variance. What is the meaning of high variance, class? Variance gives us what information? Variance actually gives us that how much variation is there in the whole data set. That is your variance. How much variation is there in the whole data set? Okay, so if there is a very high variance, then if there is a very high variance, okay, then you will not drop those 70,000 rows. Why? Think about this. Now, suppose let's say in a class, sorry, um, wait. Let's talk about COVID. Okay. So in the COVID, there are limited number of variants, right? There are limited number of COVID variants. I think 4, 5, whatever. Let's say 10 variants are there of COVID. Okay. Now, class, we have data records of 1 lakh people. Now, this 10 variants, okay, of coronavirus are basically present in this 1 lakh people all over India or maybe all over world, whatever. Okay, doesn't matter. But so you can see that variation is very less. Variation is very less among the people. Only 10 variants are there. That's it. Okay, that means repetition will be very high. A lot of people will be having the same variation, right? Will be a lot of people will be getting affected due to the same variation of corona, right? Okay, that means very low variance. Very low variance is there in this particular problem statement that I just explained. Okay. So in that case, you will not. In that case, you can delete. Sorry, in that case, you can delete. When there is a less variance, yes, in that case, you can delete 70,000 data records. Because you know that okay, you won't miss out on like important information even if you delete the records. Okay, but what happens, guys? What happens if there is a, let's say there are 100 variations, okay, or maybe let's say there are 200 or maybe 500 variations in 1 lakh people. Okay, 500 variations or even 100 variations is a very big number. Okay, is a very big number. Okay, so in that case you will not delete those 70,000 records because of high variance, high variation in the data. Because why? Because you might lose some important information if you delete those data records, if you delete those rows from the data set. Clear, class? This is about your handling missing data completely. Okay. So see, there is no rule book properly. Like I won't say there is some rule book or anything. It is completely like it will completely come by experience. First thing, okay, and it basically the same thing. Like same thing is dependent on multiple other factors also. Right? Okay, the data set is of which sector? Okay, if it is of healthcare sector or maybe finance sector or maybe sports, okay, or e-commerce or whatever sector it is, the data set is coming from which sector. On that particular data is all your handling will be dependent on. Okay, how much data is there? How many columns are there? Okay, columns there. What is the weightage of different columns? How many rows are there? Okay, how much variation is there in the rows? How much missing data is there? How much percentage of missing data is there? Okay, in that column, how much missing data is there in other columns also? It will be depend. It will be depending on that also. What application we are going to build? Okay, what analysis exactly we're doing, what kind of analysis instead. Okay, tomorrow, sorry, later I'll explain one more thing. There are different types of statistics analysis also. Okay, so what kind of analysis we are doing. Okay, so it depends on a lot of factors. Okay, how to handle missing data. There is no proper rule book present. Okay, so it will completely come by experience. First thing. Second thing, a lot of times we go by intuition also. It okay, we don't need this, and that intuition will develop over time. Obviously not now, but it will develop over time when you gain the experience. Okay, so class, let's continue now. Okay, so handling missing data we have seen here in the ADA part. Okay, let's continue. Now, class, the next analysis that I have to do is basically on the fair column. Okay, basically I saw here that okay, some people, let's see, I was just randomly making some observations in the data set. Okay, so I saw that some people paid zero. Okay, so how is it possible? How is it possible that some people paid zero money on for the ship? That is not possible, right? Okay, so now there is a possibility. See, in the Kaggle, we will study that the dataset is basically containing the details about crew and passengers, both of them. The crew members and the passengers, both of them. Now, can we safely assume, class, not with 100% confidence, okay, but can we assume that the people who paid zero money, okay, are basically the crew members, are basically the crew members, okay, on the ship, okay, that is a possibility, right? Okay, because passengers are not going to pay zero. Okay, only the crew members are going to pay zero. So it is a possibility. So I've taken out fare equal to zero. All the people, all the passengers who paid zero money here. So now I'm assuming that these are crew members. Okay, so you will write here. Possibly these are crew members. Now class, here was your observation, right? You observed that okay, there is some zero, there is some data, there is some fare data with zero value. That was your observation. On the basis of observation, you assumed that they are crew members. Okay. So first, what happens? See, first your observation comes, okay, and then assumptions come. On the basis of assumptions, you will develop some hypothesis. Okay. You will develop some hypothesis, and then you will study it. And you will study it if that particular things, the particular hypothesis holds true or not. Okay. So now let us check that class. Here you can see that the people who paid zero money, okay, have zero siblings and zero parents. That means obviously the crew members are not going to, they won't be having their relatives, right? On their no relations or anyone on the ship, right? Then first thing, they all of them boarded from the S location. That means obviously, see on the Wikipedia you will see that the ship started sailing from Southampton, S was the first location from where the ship boarded some people on it. Okay, so obviously the crew members are going to be there on the ship right from the starting. It means S location. First thing. Second thing here, class, on the cabin column, most of data is missing. For most of them, data is missing. For those the data is not missing. That is your B94. Here you can see that is a first class person. Okay. A36 again first class person. B102 again first class person. So there is a possibility that these people are on the higher post, are on the higher post on the ship, maybe captain or someone, right? Then you can see majority, none of them survived. Only one of them survived. Yes. Okay, but majorly none of them survived. So obviously that we know from the experience that the crew members are going to give more preference to the passengers. Crew members will give more preference to the passengers on ship always. Okay, so that is why they didn't survive here. Okay, P class is mixed. Okay, then you can see on the in the sex column that all of them are male. All of them are male. Okay, so now C class, your survived column, sex column, SIBSP parch, fair column, and your barred column and your cabin column. All of these columns are basically giving us, telling us that these are possibly crew members. So when you observe something, okay, you assume that okay, these are crew members, and that time you were not very confident. Okay, you were maybe 10% confident that okay, these are possibly crew members. But now, when you developed your hypothesis, class, when you developed your hypothesis based on multiple observations, on multiple columns, you now have a higher confidence on this particular assumption. But okay, earlier you were 10% confident, now maybe you're 70 or 80% confident that okay, these are crew members. Okay, so this is how we proceed. Is it clear, everyone, so far? Is it clear, everyone, so far? Please respond. Hello. Okay. So let's continue now, guys. See, on this now, I'm basically running multiple queries. The person who paid fare 0 and where P class 1, fare 0, P class 2, fare 0, P class 3. So I'm trying to study them. Okay, maybe I will be able to see some similarity between them, possibly. Let's see. Here in the ticket column, P class 1, fare 0. Okay, so ticket you can see for all of them, it is 112 in the starting, 112, 112, 1120, or even 11205. The first 5 digits of the ticket is same for all of them. Not for the last one, obviously, but for rest of them, it is same. First observation, class. Okay, they are basically from upper, like older people, right? Obviously, because there are because they will be in higher post. Okay, and that is a P class 1 also. Then P class 2 class. P class 2, we see that the ticket, the first 5 digits is same here also. 23985, 23985. For all of them, 23985 is same in the ticket column. Okay. Age data we don't have, so we can leave it. In the P class 3, for all of them, ticket is line. Line, 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 line. So possibly they were not provided something any ticket, or maybe on the ticket line was written because they were lower class professionals, like lower class workers on the ship. Okay, maybe the people who work in the engine room or whatever. Okay, so P class 3. Class. Let's continue. Now I'm going to study the P class 1 data. So in the P class 1 data, we will start to do some observations and hypotheses. Right, P class 1. One observation I have already given you in the ticket column. Okay. Then we have to take P class column and the embarked column. Suppose class, let me give you an example here. And let me give you a very live example. All of you must have seen advertisements, right? All of you must have seen advertisements during Diwali, okay? Diwali or Holi, right? Whenever there is some sale, right? During Diwali, okay, there is sale, okay, on Amazon, Flipkart, okay, multiple e-commerce website, right? Now what happens? Suppose, think of this in this manner. Suppose I am from Amazon, okay, and I want to do some marketing. I want to do some marketing because of this, because of the ongoing sale, right? Now I have to decide that, okay, how much percentage discount should I give on different items on Amazon. Suppose there is your clothes are there, right? Clothes are there and gadgets are there. Okay, so not let's talk about gadgets first. Now I want to decide that, okay, how much discount should I give on the gadgets? Or let's say phones, mobile phones. Okay, how much discount should I give on the mobile phones? Now, class, obviously, I'm not going to run the ad of each and every mobile phone. See, there are hundreds of mobile phones available, right? First thing. Plus, mobile phones are of different ranges. Okay, they are like in the range, like price range of maybe like if you're talking about smartphones, so they're in the price range of 5,000 to, let's say, 30,000. This is lower end phones. Okay, then middle end, okay, your 30,000 to, let's say, uh, 60,000. That is your middle range. Okay, then upper end phones, higher end phones, that is your 60,000 to 1 lakh or maybe 2 lakh or 3 lakh, whatever. Okay, that is your higher end phones. Now, obviously, I am not going to run advertisement of each and every price range everywhere in the whole country. There is no point, right? Because if I'm running ads, so I will have to spend some money also, right? So let me take an example. I'm talking about, let's say, Delhi. Okay, let's say I'm talking about Delhi. So if I'm running a particular ad in Delhi, so obviously I will not run the ad for all the phones in Delhi. I will run, yes, okay, but I will spend different amount of money. Okay, okay, so I will, for that I will need to do an analysis that, okay, people in Delhi, let's assume that people in Delhi are more likely to purchase higher end phones, are more likely, okay, to purchase. There is a probability, the probability of people purchasing higher end phones in Delhi is high. Probability is high. So now, based on this class, based on this, obviously I will run more ads of higher end phones in Delhi class. I hope everyone is getting this. Let's take another example here. Suppose I did some analysis on the basis of which I saw that, okay, the people of, let's say, maybe uh, Himachal Pradesh. Okay, the people from Himachal Pradesh, okay, are going to purchase middle end phones more. Middle end phones, okay, more. So what will happen in that case, class? Middle range phones more. So in that case, I will run more ads of the middle range phones in Himachal Pradesh. So people in Himachal Pradesh, okay, they're going to see more ad. There are multiple places I can run ads, right? Okay, maybe in newspaper, okay, maybe in your games, in different applications. On Google I can run ads, okay, on Amazon itself I can run ads, okay, at multiple places I can run ads for the same. So I will run more ads about middle range phones in Himachal Pradesh. More ads. I will maybe I will spend 2 lakh rupees on middle range phones. Ads of middle range phones. 1 lakh rupees on lower end phones. 1 lakh rupees 1 lakh rupees on higher end phones. That's it. But 2 lakh rupees on middle range phones. Why? Because people are more likely to purchase it. Okay, so this is where your this thing comes in. That okay, peak. You can we were talking about the P class, right? In the Titanic. So I want to see that okay, which people like the upper class people boarded from which locations. I will take P class and the embarked column, both of them together, and I will study df P class equal to 1 and and ampersand wala and embarked equal to s. Same thing, P class equal to 1, embarked equal to c, P class equal to 1, embarked equal to q. So I will run these three queries separately class and I will see that okay how many people basically boarded. See P class 2 I am taking, P class 3 I am taking. Just give me a minute. Okay, I started this example, but I've written it somewhere later on. Here you can see class. Q, how many people location of how many people from Q location? Okay, we are from third class. Okay, 72 people. See, 72 people from Q location were from third class. How many people from Q location were from second class? Okay, that is you can see 3 people only. How many people from Q location were from first class? Only 2 people. Same thing I will do for C location also. How many people from C location were from first class? How many people from S location were from first class? So I'm going to do this for all of them. All the so there will be 9 combinations, right? 3 possibilities of embarked, 3 possibilities of P class. So 3 into 3, 9. 9 data frame I will create separately and then I will study them, okay, to see that okay if I can see any similarity between the people, okay, or if not even then, not even that, I will be able to get at least I will be able to get that okay how many percentage of people are from first class in the S location. See class, remember that whenever the data set is biased, now what is the meaning of data set biased? Biased means that the number of people boarding from S location and the number of people from C location and the number of people from Q location is not same. That means the data set is biased. Same thing, the number of males on the ship, okay, is not equal to number of females on the ship. That means the data set is again biased. It is not balanced, na? It is not balanced. Okay, so you cannot take numbers into consideration when you are comparing them. Rather, you have to take the percentage. Okay, how many percent of people from S location are from upper class? How many percentage are second class? How many percentage are third class from the S location? And then you will compare the percentages, all the percentages, and based on that, you will be able to understand that okay, I'm giving example right now. So maybe you will find out that okay, from the S location, majority of the people boarded were from P class equal to 1. What is the meaning of this class? What is the meaning of this? That the people who can afford a costlier ticket, okay, costlier ticket were boarding from S location. That means that S location is a post location. We can safely assume this. Okay. Same thing happens in here also as an example I was giving you. In that case also we basically analyze city wise. city wise also, state wise also, both. Okay, we will do, we do region wise also. Okay, if we do region wise also, state wise also, city wise also. Okay, we see that. Okay, for different cities, for different states, for different regions, we do country wise also. Okay, so we basically see that. Okay, that people, how much people are willing to pay in which location. Okay, based on their socio-economic status, how much people are willing to pay for different things, for gadgets, for mobile phones maybe. Okay, for different gadgets, maybe for clothes maybe. Okay, suppose I want to see that. Okay, let's say if the people can, sorry, uh, let's take an example of your watches maybe. Let's say watch. Okay, so suppose if I want to see it. Okay, the people are going to purchase uh, watches in the range of 1 lakh. Okay, maybe Rolex and all in this location. From this location, people are more likely to go with Timex. In this location, people are more likely to go with the price range of Titan. Titan is somewhere around what? I guess 2000 to 7, like starting is 2000. Okay, for Timex, you can go for 10,000. Okay, similarly, like, there are different things available. Then we see the age group also. We see the age group also, right? Okay, if I am selling phones, okay, so phones are going to be purchased more by middle aged people, right? Maybe somewhere above 25 to, we can take 40 or 45. From 25 to 45, those people are more likely to purchase phones, mobile phones. Okay, and again, higher end phones also. Higher end phones also. Okay, so that age also takes, we have to take age also into consideration. Then we have to take your uh, sex also into consideration for people. Okay, right, okay, male people are going to purchase, let's say, gadgets more. Okay, females are going to purchase clothes more. Okay, I'm giving example right now. Okay, so based on all these things, class, we decide that, okay, what to do. We make a complete report of the analysis. Okay, so yeah, that is all for today, class. Tomorrow we are going to start a new topic. Okay, we are going to start your statistics. Okay, and that will be majorly theoretical. Not completely, but majorly it will be theoretical only. Some part of statistics I have already covered in the class, such as your descriptive statistics, inferential statistics. I have already covered IQR, variance, standard deviation. Okay, then your handling missing data. Some topics I have already covered. Okay, rest of the topics I will cover from tomorrow. Okay, so yep, that is all for today from my end, class. Okay, everyone.